And just hit the record button so that we have it. Great. So, Erin, I'm Mary Dussault. I'm the principal investigator for the NSF-funded YouthAstroNet project, and I'm here in the Science Education Department at the Harvard-Smithsonian Center for Astrophysics. Behind me here and also on the line is Erica Wright, and she's an education specialist in the Science Ed department here. And she's kind of a key contact point. You've probably already gotten emails from her about this very webinar for the project. Also on the core team here at the Observatory is Frank Sinkowitz, who's our telescope engineer, and I'm going to tell you a little bit about the telescopes in a bit. Aladdin Ibrahim is our IT specialist, and he's developing the online learning environment for students to participate in YouthAstroNet. We have a bigger team here that is, let's see if I can get there, the research team, because this project we not only have a program that has lots of fun activities for students to do, but NSF has funded us to conduct some research on what aspects of that program end up stimulating students' interest in STEM careers and science and in learning science. So our research team is Phil Sadler, Gerhard Sonner, and Annette Trenga. And then we have all these staff from the observatory, scientists, engineers, undergraduate students, grad students, our public affairs person, who have all agreed to be online STEM mentors for students who participate. So your youth can get online and ask questions of people who are in science here at the observatory and learn about their careers as well. So the things I want to go over in the next 20 minutes or so include background information on the program and introduce you to what the research is and what the program is and how it is that you can go about training yourself in a self-paced way to implement the program for students. Erin, can I just ask, are you a after school or school-based educator?
Yeah, so I'm at the Challenger Learning Center. So during the school year, it's mostly field trip groups coming in that are a variety. And then in the summer, we have kids that are with us for a week. So
oh, great.
More in-depth stuff where it'll probably be mostly with them. Okay, great.
Great. So yeah, the program's used by educators in lots of different contexts, and those two examples are, we certainly have educators in both situations. The Center for Astrophysics is one of the largest research organizations for studying astronomy in the world, and Erin and I are seated right here in the building, the brick building that's in the upper right of this slide. And so the astronomers here study everything from the sun and near-Earth objects in the solar system to stars and star birth regions, to black holes and galaxies and deep space and cosmology. And there's also engineers here. We have a big group that designs instruments for both ground-based and space-based satellites and telescopes. In the bottom right there is one of the engineers working on the Solar Dynamic Observatory, which is a NASA satellite. Now it's in space, but the actual telescope parts were actually engineered here in Cambridge, Massachusetts. So in addition to being a research organization, we also have the Science Education Department that does that develops materials for learning, both for schools and for out-of-school environments, museum exhibits even. And we also do research on how students learn and what kinds of factors promote student persistence in wanting to be involved in STEM careers. So the key asset of the YouthAstroNet program is actually our robotic telescope system. It's called Micro Observatory. And in this picture, we have, you can see 2 of what is a set of 5 automated robotic telescopes that can be controlled over the internet by your youth. These 2 are named after Ben Banneker and Cecilia Payne-Gaposchkin, 2 noted astronomers. And our other 3 telescopes, those are B and C, are A, D, and E, Annie, Donald, and Ed. And you can learn about who our telescopes are named after on the YouthAstroNet Portal.
I got to see the one that's on top of one of your buildings, and I got to visit for a conference. So yes, those are
right. Oh yes. Okay. Great. Yeah. So I think that was. Well, that was actually probably Ben, who's moved from Arizona up to our roof.
Okay.
Now. Yes, exactly. Yeah. So YouthAstroNet basically builds on what we've learned using Micro Observatory for the last 10 years in terms of how to make it accessible to students and what kinds of activities are engaging. And it's funded by the NSF ITEST program, and ITEST stands for Innovative Technology Experiences for Students and Teachers. The goal, NSF's goal for this program is to learn how and to develop programs that help prepare diverse, skilled, and innovative STEM workforce. So our own intended outcomes for the project include both some astronomy learning, but also probably more 21st century skills and also science identity, kind of engaging kids in a fun way with science practices that helps them develop an interest and disposition for STEM careers. So those are the outcomes, but in order to figure out how to promote those outcomes, the project has an important research aspect to it. And so the key thing to be aware of is that right now the educators who we're recruiting we're asking to be willing to participate in the research study aspect of the project in addition to implementing the program with youth. And what that means is that you're willing to take a pre-program survey, a mid-survey after you do the online training workshop, and a post-program survey after you implement with students. And also that you be willing to facilitate the parental consenting process for the kids that you engage in the program. And we provide all the forms for parents to sign and a letter explaining the project, but we do ask that since you have access to the kids and they have access to their parents, that you help facilitate that process. The one thing about all the research is that the surveys do take time, and so we ask that you reserve time at the beginning of your program and the end for the students to spend 20 to 30 minutes taking this survey or to facilitate their taking it. And here's some examples of the kinds of questions. It's not really a, while there's a couple of content questions, it's not really a survey that's high stakes in terms of content or anything. It's more about interest, whether students talk about science away from school, and whether they have any interest in STEM careers. So here's what a YouthAstroNet program is in its core implementation. It can be lots of things. I mean, there are lots of resources. Educators can, there's enough different kinds of things you can do with the telescopes that it can be a 3-day program, or it can be a semester-long or a year-long program, after school club or something like that. So, but the essential elements are that students learn to control our telescopes and to use image processing software, that the end result of learning that is some sort of product, whether it's a display, a poster, a website, an online wiki. A lot of our participating educators have done parent events where students teach back what they learned. And so that's kind of the essential element, and students end up learning different kinds of content depending on the particular scope and sequence of activities that you might choose to implement with them. So you might focus on learning about light and color, or you might focus on learning about digital imaging and how instruments, how cameras work and how image processing works. Or you might focus on learning about the actual objects that students take images of, whether it's the moon or distant galaxies. So those are the essential program elements. And here's some examples of capstone projects that students have done. In the lower left here, a museum in Miami, Science Museum, actually had a tech center where they taught kids how to create movies using iMovie or whatever. And so their capstone project for the YouthAstroNet project was to have students make 30-second videos teaching that presented some kind of message using images they had taken with the telescope, and putting it all together in a little 30-second clip. Here's a public community event and students' posters. You can see this is very low tech. This is more high tech. Here's students creating an astrophotography display in the lower right. So there's lots of different options for what that capstone event might be, and the online learning environment, both for educators and students, has more examples. So there's the essential elements of using the telescopes, taking images, processing those images, and pursuing some sort of project. But then there are additional activities to do on the online workspace. And there's also access to mentors, the people I mentioned at the beginning of this presentation. And you have an opportunity to schedule behind-the-scenes virtual tours or interactive Q&As with scientists here. So using the same technology we're using right now, you can book a Q&A session with a scientist as part of your program if you want. And so there's, and students who complete their projects get completion certificates. And we're also working on opportunities for parental participation that is still new and yet unformed. So any suggestions on what those look like are welcome as well. The online learning environment is, we use open source tool called Moodle. I don't know, you might be familiar with it. And the online environment is password protected, and there are accounts for educators, and then you get a group account for any group of youth that you might work with, and you can get multiple group accounts if you work with multiple groups, or if you do a program that's, you know, 2 or 3 day workshop during one part of the year, and then you do another program that's a week-long camp in the summer, you would have different accounts. The portal I'm going to bring over into the view of the shared screen here. If you, microobservatory.org gets you to our public interface to the telescopes, but the YouthAstroNet portal is down here. It's this little link here that says YouthAstroNet Portal, and when I click on that, you can see there's the activity portal, which is basically the learning environment that is used to access the telescopes, and that students use, and that you use as well when you're learning after this informational webinar. If you decide to join us, you'll use the activity portal to learn how to use the telescopes. And that looks like this, and there's so the access to the telescopes and to the image processing is customized specifically for participants in YouthAstroNet. I'm going very quickly through this because the recorded webinars that you would view teach you how to use this portal to request images from the telescopes. But this is the youth portal, and the educator portal looks like this, and this is basically the place where over the next few weeks, as you're trying to learn how to implement a program and how to use the telescopes yourself, and what you might do if you implemented it with students, we essentially have a training checklist here, and I will open that up for you. And basically, your mission to learn how to implement YouthAstroNet is to kind of look through this checklist of activities to do on the educator portal, which includes you yourself taking some images, processing them, and posting them to the online learning environment, so we know that you know how to use the environment yourself before you implement with students. And it helps you think about how to plan how you would use this online portal with kids. So that's the educator portal, and you can, you know, as you go down and try things out, you can check them off yourself. This portal also contains, when you ultimately get ready to implement with students, everything you need to prepare for implementation, including materials for signing students up. It includes all the curriculum for using the telescopes that you could use. There are lots of activities: introduction to image processing, activities around exploring light and color, activities around exploring size and scale, activities around exploring the moon, activities around exploring pixels and digital imaging. So there are a lot of curriculum resources, as well as at the very bottom, tutorials on both how to use the telescope and on how to use, create wiki pages and use the learning environment itself. And at the bottom, at the very bottom of the educators page, is where the recorded webinars are for the training, and there's basically 3 webinars. What we're doing right now is not webinar number 1, it's like information session 0. So you would watch webinar 1, where we show how to use the telescopes and open an image that you get back in the image processing tool. Webinar 2, you really learn about light and color, about filters and how the telescope uses filters, and how to create an RGB true color composite image from 3 separate images taken by the telescope through red, green, and blue filters. And then webinar 3 is really going over a few more activities. In particular, you have the option to borrow kits of electronic parts. We have design engineering challenges associated with the project around developing the submodules of a robotic telescope. So how would you design a circuit that senses light and measures the amount of light coming into a sensor? That's what a CCD camera is. How would you design a motor that can turn a telescope body and aim to any part in the sky? Webinar 3 shows some of those design engineering challenges. And so this is, you know, we have a few people joining now, and so we're encouraging you. This is not on our regular cycle of Youth Astronet Educator Professional Development, so we're kind of encouraging you to watch the webinars in a self-paced way. But at the same time, Erica is going to be available over the next few weeks. If you want a personal tutorial, or you've tried something out, you've watched the webinar, you don't know how it works, Erica will be available to help with specific aspects of the Youth Astronet program.
And don't forget to print out the forums too.
Yes. So the other, so if you look at this workshop training checklist, you'll see that first thing is to view the live webinar. Actually, it won't be live, will it?
No.
View the recorded webinar. We'll have to. And then to introduce yourself using the forum, introduce yourself. So if we go back to the, you can see here's the forum, introduce yourself. And you'll see we have lots of educators who've introduced themselves and learned how to post an image to a forum. And so your first task in the training is to do that. And there are forums throughout the training. Here's the forum where educators posted their images. And so you can see lots of educators have practiced using the telescopes and using the image processing tool. And so that's a early kind of assignment of the self-paced training. Something else you wanted to make sure I got to?
No, I just meant the forums for asking questions.
And Erica wants to make sure that you know you can also ask questions in these forums here. So if it's a technical question about micro-observatory, questions about the activities and resources for Youth Astronet, there's forums for that as well. So that
we will be monitoring.
And yeah, and we monitor them. So we'll answer any questions that come in, and we have our whole team answering. So, all right. So that is kind of how the training works. Let me put this out of the way here. I don't know where that just went, but and so you're going to learn, and following that, your students learn how to send a request to the telescopes. And as you learned when you saw the one here on the roof here, they operate once a request is sent that night. The telescope springs into action, taking all the requests that came in. with no human intervention in the loop. And then the next day, those images wind up in your YouthAstroNet portal account. Whether it's an image of the moon or a distant galaxy, you can open those images in the browser-based image processing tool that the project offers and learn how to enhance the images in different ways. Of course, the telescope only sees in black and white. The detector only detects areas where a lot of light comes in or where a little light comes in. So you can either use false color, as this moon is using a false color palette to highlight different aspects of the moon. Or after watching the recorded webinar number 2, you'll learn how to combine 3 seemingly black and white images taken by the telescope, but they were taken, one only letting red light through, one image only letting blue light through, one only letting green light through, and using a computer to tell the computer, this is the red channel, this is the blue channel, this is the green channel. You can create a color image that actually is representative of the actual colors being emitted by the object in space. So these are some examples of this idea of a virtual field trip. That's an opportunity that you can take advantage of. And you can take advantage of it actually during your training if you want. You can just tell Erica, I really want to find out more about this, and we'll schedule something for you. But you can also schedule virtual field trips for your students. So your next step, should you choose to proceed with the project, is to spend 8 or so hours exploring that educator portal and the youth activity portal that I just showed you very briefly, watching the recorded webinars, using the forums to both introduce yourself and ask questions as you try out the various activities, post some images on the forum, and actually create a wiki page. The capstone project of the training is you'll end up creating, whoops, go back, creating your own wiki page of how you plan to implement YouthAstroNet for a group of students that you engage with. So we're hoping that as you become a part of YouthAstroNet, we'll help you develop some skills and teaching strategies for implementing the project, and that you develop some confidence that you can implement the program successfully yourself. I think that's it, except for the immediate next steps, which would be to first confirm your participation. Now that you know a little bit more about what YouthAstroNet is and what you'd be getting yourself into, in order for us to create an account for you on the YouthAstroNet portal, we need you to create a new Gmail address. And you probably don't want it to be a Gmail address that you use frequently, because we're using it to create the group student accounts on the YouthAstroNet portal, and it allows us to create accounts for all the students that you might engage and keep them anonymous under that unique Gmail address. So that's the first step. Send that to Erica. We'll send you, Annette Trenga actually will send you an email that is specifically asking you to consent to participate in the research, and that's the part of the project. that involves you agreeing to take surveys and helping facilitate your kids taking surveys. And also, as an educator implementing YouthAstroNet, you're eligible to, after you implement and take the pre and post survey yourself, have students take that, you're eligible to receive a $250 stipend. So that's what that consent request is about. And then the final immediate next step before getting on the portal is to complete your own pre-survey before watching the first webinar. And we want it before you watch the first webinar, because then it's truly a pre-survey. So that is, that it? Oh, wait, stop it. I lost it. So that's kind of the information we have to share with you. And